I'm Karen Dunville and I'm here today with Erik Dornenberg, CTO Europe at Thoughtworks, who is going to share some insights with us on how AI-assisted software engineering can revolutionize legacy modernization. Hi Erik, thank you for joining us today.
Hi Karen, glad to be here.
Well, let's get started. Can you introduce yourself and share a little bit about your background in software engineering and AI?
As you said, Karen, I'm CTO Europe at Thoughtworks, which means I'm a technologist. I have a background in software engineering and computer science. I've literally done AI since the 1990s. This has been around that long, and I've always been, and therefore that's the reason why I'm at Thoughtworks. Always at the pioneer at an early wave of adopters of new technologies, and I'm now seeing the application of Gen AI and large language models in software engineering as something that is currently state of the art.
Terrific. Thank you. Let's jump in. Can you explain what AI-assisted software engineering entails and describe the role of large language models, LLMs, in this context?
Software development really is creative work. It's a team sport. The technology landscape changes all the time. We need to talk to multiple people. We need to learn new technologies. There's new concepts coming up. We need to process information. A lot of what we do with both the understanding of new technologies, but also the actual expression of what we want to program, what we want the computers, the systems to do, is in textual form. Even the infrastructure today, with infrastructure as code, everything is captured in text. And by chance, large language models are excellent at modifying text, at interacting with text, taking text as input and producing output. And that's what not only we, but many others have also noticed. That is why large language models can help us with any number of tasks while delivering software, be that new software or what we talk about today, dealing with existing legacy software.
Great. And just expanding on that, what specific advantages do large language models offer for legacy modernization, particularly when compared to traditional methods?
When I talk about legacy modernization in this context, what I mean is taking systems usually decades old, like from the 90s, usually mainframe systems, or say a Java-based system from that early wave of Java software in the early 2000s, taking that and replacing it with new software. I'm not talking about changing the decades-old COBOL code. I'm talking about taking that system and creating a new piece of software. What the LLMs really do here, what they offer that traditional approaches can't do, is they can go through large amounts of information and summarize them, for example. They can process the unstructured text. They can perceive connections in code that you would otherwise not necessarily see. I mean, I'm always giving that as an example. We talk about 1 million lines of code in contexts like this. If you print 1 million lines you wouldn't do it just to give you a sense of the size. If you print a code base with 1 million lines of code on paper, that's a stack of paper that is 1.5 meters tall. So if you're now saying, look through that or find all the places where a certain policy is implemented, find all the connections between those. As a human being, I literally can't read through the code base. I need to rely on something. So far, we've often used tools that look at the structure or just as text, almost like you press Control F and search for something. But the benefit the LLMs bring is that they have a deeper connection. They can explain what the code does, not only step by step, but to a certain extent, they can describe the intent of what the code wants to achieve and not every little step. And that's really a huge benefit for software developers to understand an existing large code base with the aim of modernizing it.
Sounds like a great benefit. And in what ways can reverse engineering tools be integrated with LLMs to enhance and speed up legacy modernization?
That's an excellent question. And that is something that we've learned over the past year, I would say. Initially, the assumption was that you could just feed information into a large language model and the model would answer the questions. That gave a lot of different issues in the end. One of them were these dreaded hallucinations where the model would make up things that weren't actually correct. But also, it wouldn't really be concise enough in their answers, especially when it comes to understanding code bases. So what we've seen as an industry in many different areas is a pattern, and computer science people call it RAG, Retrieval Augmented Generation. And that is a way that allows us to nudge the large language model in the right direction by giving it specific information that we find with other means, usually with a search. and then that way help the large language model to come up with better answers. An approach, by the way, that reduces the hallucinations to, it's not even an absolute minimum. It's not really in that area of application an issue at all anymore. What we've then said is, okay, if we take the large language model and we need to feed it additional information in this RAG, in this retrieval augmented generation approach, where does the additional information come from? A simple approach is, and that is being used when you're writing new software outside legacy modernization, anything that the software developer, the engineer, has opened in the editors, and take all those windows and feed that as additional context. With legacy modernization, that is not the best approach. What we've seen is we've used traditional, as you said, Karen, reverse engineering tools that understand at a structural level the old source code. We are pre-processing this before we actually begin the modernization, stick that into another system, a database in technical terms, and use that information as input to this retrieval augmented generation step. So we're basically taking the proverbial best of both worlds. We're taking the structural understanding that existing reverse engineering tools have, but we combine it with that higher level understanding that an LLM can give us. And the combination of both has really helped us to understand existing code bases better. And especially, that's something we didn't talk about so far. A lot of the old code is written in languages, the mainframes are often programmed in COBOL, that many software developers today are not so familiar with. And that again is something where the reverse engineering tool can unearth the underlying structure, and the large language model then on top can help the developers understand how that code works. We assume, of course, that today's software engineers master today's tools and write the new software. But the large language model, in conjunction with the reverse engineering tool, really gives the developers a deep understanding into a code base, into technology that they're not as familiar with. And it's often hard, to be honest with you, to find people with the engineering skills that you would need to do this in a human-centric way.
Brilliant. Now, my next question is a two-part question. So what practical advice would you offer to developers and companies looking to adopt AI-powered approaches for legacy modernization? And how can developers and companies prepare to effectively use large language models for legacy modernization?
Let's start with the second part of the question, maybe. And when it comes to preparation, it is often making the data available in the first place. As we see in many other areas of the use of AI, of Gen AI solutions, the data is often not in a format that allows it to be utilized by an AI-based system. So when we're talking about legacy modernization, make sure that the source code is actually accessible to the AI solution. Make sure that you have a tool that can, we talked about the reverse engineering tools, that can actually understand the programming environment that you have. We had this with a client in the UK recently. They were using a specific dialect of the COBOL language. And we first needed to figure out a tool that could actually parse, understand, and ingest the information there. So make sure that you have those in place. Documentation, I mentioned before, if you can, try to figure out what is the right documentation. I mean, oftentimes when a system is 20-year-old, you have documentation and you don't really know anymore, is that the right documentation? You might even find that the documentation contradicts itself, that there's a document from the 1990s that says something different from 2010, and you don't know which is right. You can even use an LLM maybe to find out these cases, or you could actually try to figure out, does the documentation contradict what is in the code? So doing that. And as a last thing that you could do to prepare is to have automated tests. That can be a difficult thing to achieve. And I'm saying, don't do this just to do it. But if you can, and there's a good way of doing it, maybe have a number of end-to-end tests that you can keep running to see if you're making tweaks to the software, if you want to validate a hypothesis on the old code, that you can make sure that you're not breaking functionality. That is more, I wouldn't say a bonus. It's something that you should consider, but not do blindly. Whereas getting your information available, the documentation ready to be fed into the large language model, or the source code, of course, and the reverse engineering tools, that, of course, is a must. And in answer to the first part of your question on the practical advice, do not expect shortcuts. There is no system, at least to my knowledge and based on everything I've seen, that will completely translate the software for you. The practical advice is take the large language model, take the Gen AI-based system, as a guide, as something that helps you navigate the old code. Familiarize yourself to a level that it makes sense to you, that old code. But of course, as I said before, you don't have to know it in detail, because the combination of reverse engineering tool together with a large language model will actually support you very well in that.
Great, thank you. Moving on to a slightly different topic, what ethical considerations should organisations keep in mind when utilising large language models for legacy modernisation?
Yeah, that's of course a topic that often comes up, and rightly so, in the use of any AI system. I would say the good news here in this field of software engineering is that we are not struggling as much with the ethical problems here. A lot of the standard problems that you see in machine learning models, for example, bias in the training data, is not so much an issue here. In fact, I would argue bias in the training data could be an advantage in this case. So if you will, there's often, in the same way as we all have our own idiosyncrasies when we speak a natural language, organizations will have a certain style, a house style of writing code, certain patterns that they prefer, the development teams prefer. So if you now have a language model that is biased towards those patterns it sees in the code, it is actually here a benefit, because you want to replicate that bias that you have in the system. Whereas, of course, in other systems that we have where we're dealing with personally identifiable information or financial data, then we don't want that bias. So one of the bigger problems really isn't here anymore. Another big problem, of course, that from an ethics perspective is the intransparency or opaqueness of the decision-making process. I mean, this was, of course, in the press even years ago about using AI-based systems or algorithms for making credit decisions. And then, of course, as a financial institution, you would be obliged, I would assume so anyway, to be able to explain how a credit decision was arrived at. When we talk about legacy modernization, that in turn is not an issue really, because as a software developer, I don't care, to be honest. I mean, as long as the model can tell me, the combined system can tell me where I can find the pieces of code that deal with a policy, I'm happy, because that's what I need to replicate. I do not really necessarily, or actually not at all, care about how the system arrived at that. So that's the second one that is not really an issue. And the third and last one that I'm going to talk about are hallucinations. And the hallucinations, as I said before, are really minimized by the use of the retrieval augmented generation pattern. So the answers the system is giving are really, and they are not that prone to hallucinations because of the approach. And in the end, if it spits out something that doesn't work, it doesn't work. You know, I mean, it's obvious because it's program code and you can understand it that way. So I would say a lot of the ethical concerns that we normally need to take into account when we want to use an AI-based solution don't really apply in this field.
That's definitely a benefit for people. How do you anticipate the role of large language models in legacy modernization changing over the next few years?
I think what we have done in the past years, we've understood the broad direction that we need to go in. So I wouldn't necessarily expect a major change in the way those tools are set up. So what I described before, the idea that you take a foundational model and retrieval augmented generation, that pairing is a pattern that I don't necessarily see changing. So we have understood this, it works in other fields, and it works really well here. The combination with traditional structural reverse engineering tools is also something we've discovered, and it has proven itself. So I think that broad direction of using the tools in that kind of combination is something will be here to stay. What will change is the experience. We will learn more about the experience. We will fine-tune the approach. We will get more detailed data over the years that can help us refine how we do this. But the broad direction will be similar. There are areas, and I don't want to get too technical in this podcast, there are areas when it comes to the programming patterns, something that is called select and carry, for example, or using the so-called window size, the context for the prompt. These are areas where we need to investigate and experiment. For example, is a larger window, more information always better? Or is it better to do pre-selection and send a smaller set of data to the large language model? That again, that's what I meant with the tuning. These are areas that I think will evolve. One last aspect that is relevant that can change and is likely to change is where the large language model is running. At the moment, it is very common and for the right reasons to use a foundational language model. Training your own models is usually, especially in this area, really not worth it. It's very expensive. It's difficult. It's hard to get enough training data. So what we're using are these foundational models, and they usually run in the cloud. For many organizations, that's not an issue. They run business software in the cloud. They have software as a service solutions that holds their data in the cloud. But in other areas, it may not be so easy. And there's also in certain organizations a hesitation to move things into the cloud. And of course, in legacy modernization, you're talking about the crown jewels, the source code of your mainframe systems. And some organizations are, for the right or wrong reasons, reluctant to do so. What we're seeing is, coming from the consumer space, actually, a trend towards so-called small language models. And small is, well, the size of our brains, still not small at all. It's still quite large, but it is a language model that can run on a powerful workstation for a developer, or on a single server that is maybe on premise in an organization. The small language models are interested, and the consumer industry is driving them to run them on the phones, on Android phones, on iPhones, on the new so-called Copilot PCs that Microsoft has just unveiled. That innovation we can take to bring some of the approaches to legacy modernization from the large language models to small language models. And if anything, what we are seeing at the moment from the consumer approach is it may actually work. The small language models obviously are not as powerful as the large ones, but some of the limitations they have might even be beneficial. But the limitations they have might not be so bad, so to speak, that we can't use them. So that's maybe an area where we see some change, that we'll see a switch from these gigantic foundational large language models to small language models that can then be run locally, and then you don't have any issues with compliance, etc., because you can control the environment in which these tools are running entirely.
Terrific. Some insights on things to come. So just to wrap up now, what are the top 3 insights you would share about large language models, generative AI, and their impact on legacy modernization?
The first one, I can't overstate it enough. It is not going to be a tool that does direct translation. Do not expect this magic machine that you feed COBOL code and that spits out contemporary code. It is a tool in the toolbox of software engineering teams that do the modernization. It still will accelerate the work they're doing significantly, and it will also get us over the skills shortage of people who know the legacy technologies. But it is a tool for experienced development teams, not a magic translator. The other 2 pale a little bit in comparison, and here I'm showing that I'm a software engineer, so they're a bit more technical. One of them, as I mentioned before, is the application of retrieval augmented generation. That is really something that I can't stress enough. That is exactly how you want to do it. Do not expect to train your own model. Take a foundational model and use retrieval augmented generation. And then, as a third point, combine that with traditional approaches. Large language models are a breakthrough. They're giving us opportunities we didn't have, but that doesn't automatically invalidate the tools that came before it. The real power lies in combining them, in combining the newly found power of the large language models with all the engineering and decades worth of reverse engineering, combining them into an approach that ultimately makes modernization so much faster.
Thank you, Erik. I really appreciate your time today and sharing your thoughts on this topic. And thank you for our listeners in joining for this episode of Pragmatism in Practice. If you'd like to listen to similar podcasts, please visit us at thoughtworks.com/podcasts. Or if you enjoyed the show, help spread the word by rating us on your preferred podcast platform. Thank you, Erik.
Thank you.